Hi, welcome again. So let's see how the DFS algorithm will work in this graph. Okay, so at the end of the traversal, we'll find a DFS tree, and we'll also show you we'll also keep track of the start time or visiting time and finish time for each of the node. Okay. Now starting node is 1, and here we are going to use the data structure stack. Okay, so let's see how it will look like. So starting node is 1, so we'll first push the node 1, and for node 1 visiting time will be 1. Okay, so node from 1, 1 has two child node 2 and 8. Let's visit neighbor node 2. Okay, 1 has two neighbor node 2 and 8, so let's visit node 2. Okay, so then we'll push the node 2, and for node 2 the start time will be 2. Okay, now from 2 has only one neighbor node 3, so we'll visit 3. Okay, and we are actually highlighting the edges that we are using to traverse the graph, and this edge will actually construct the DFS tree, and these edge are the tree will be the tree edge. Okay, so from 2 we will visit node 3, so let's push the node 3 here, and the visiting time or start time of node 3 will be 3. Okay, 2 plus 1 3. Now 3 has two neighbor node 4 and 5. We can actually visit any one of them first. Okay, so which one we are visiting, depending on them our DFS tree may look like different. Okay, now let's see visit 4. Okay, let's see use this edge, and let's see visit 4. In that case we'll push the node 4, and for it the visiting time will be 4. Okay, now from 4 you can see we are going deep from 1 to 2 3 to 3 to 4. Now from 4 doesn't have any other unexplored neighbor node. Okay, so 4 has another neighbor node 1, but 1 is already visited, so 4 doesn't have any other neighbor node which is not visited. So from this point we will keep, now this is our dead end, and from this point we will keep backtracking. Okay, so backtracking from node, we are going to backtrack to node 3. So when we will backtrack, we will pop the node 4 here. Okay, and we'll start keeping track of the finishing time. Okay, so we are doing the backtracking. That means we finished exploring the node 4, and its finishing time will start from 1. Okay, all right, and we popped the node, so from 4 it will go to node 3. Okay, so this is now our first node in the stack, node 3. Now 3 has one unexplored neighbor node. Okay, so 3 has one unexplored neighbor node, actually couple of unexplored node 5 and 7, so you can visit any one of them first. Let's see visit 5. Okay, so 5, so what it means, we are going to push the node 5. All right, and for 5 the visiting time will be 5. Okay, so for 5 the visiting time will be 5, because the largest visiting time is 4, so for its visiting time will be 5. Okay, all right, so from 5 we'll start going deeper. So from 5 has one neighbor node 6 and 7. We can visit any one of them. Let's see visit 6. Okay, so from 3 to 5, 5 to 6, so we are visiting 6. That means we will push the node 6. Okay, so we are going to keep track of the information of visiting time, which will be 6. Okay, so 5 plus 1 6. So from 6 we can go actually more deeper, because 6 has a one neighbor node which has not visited yet, which is 7. Okay, so from 6 you can visit the node 7. All right, so which means we will push the node 7, and for 7 the start node will be 7. Sorry, from 7 the start time or visiting time will be 7. Okay. Alright, so let's see. So from 7 we cannot go actually any further deeper than that, because 7 has the neighbor node 6 and 5, all of them are already visited. Okay, so from here we cannot go any more deeper, and from here we are going to start our backtracking. Okay, so from 7 we will start doing the backtracking, and we visited 7 from 6, so from 7 we are going to go to 6, and for that we are going to actually pop the node 7, and we'll keep track of the information of finishing time. Okay, so our largest finishing time was 1 for node 4, and here the finishing time will be 1 plus 1 2. Okay, alright, so we pop the node 7, so we'll go to 6. Alright, for 6 also now we don't have any more node or any more new node to explore. Okay, so that's why we'll do the backtracking again, and from node 6 to we are going to do the backtrack to node 5. Okay, so we are going to pop the node 6 from here, and we'll do the backtracking from node 5, and before that we are going to actually keep track of the information of finishing time, which will be 3. Okay, so now 5 here, 5 doesn't have also any more node to explore. Okay, so we'll pop node 5. Okay, and its finishing time will be 3 plus 1 4. Alright, and for from 5 we are going to, from 5 the another node in stack is 3, and from 5 we are going to go to the 3 node 3. Okay, okay, so from the stack you can see actually 5 was visited from 3. Alright, so from we are going to go to the 3. Alright, so 3 here 3 also doesn't have any more neighbor node which you can explore further. Okay, so the backtracking will continue, and so which means we are going to actually pop the node 3, and we are going to keep track of the finish time of node 3, which will be 4 plus 1 5. Okay, alright, and 3 was visited from 2. Okay, so we'll backtrack from to node 2. So same here, 2 doesn't have any more neighbor node which we can visit further. Okay, so all other 2 doesn't have any more neighbor node actually, so from 2 also we are going to actually backtrack to node 1, so we'll pop the node 2. Okay, alright, and before that we'll we'll keep track of the information of finishing time node 6, and we are going to backtrack to node 1. Okay, alright, so now our stack is actually look like this. Okay, let's draw the stack again. Our stack looks like this, and stack has only one node 1. Okay, now from 1 we have actually one node we can actually visit further, we can go more deep from node 1. So we have one unvisited child 8 from 1. Okay, so which means from 1 we are going to visit node 8, so we'll now push node 8. Okay, so when we are pushing the node 8 we have to use the keep track of information of the visiting time. Okay, now visiting time will be our last visiting time, largest visiting time was for node 7, which was 7, so it will be node 8, visiting time will be 7 plus 1 8. Okay, alright, so from 8 we can go further deep to node 9 or node 10. Okay, we can visit any one of them. Let's visit 9, which means we'll push node 9 in the stack. Alright, so its visiting time will be 8 plus 1 9. Okay, now from 9 we can go to node 11. Okay, let's go to node 11. Its visiting time will be 10. Okay, so from 11 there is one neighbor node which we can visit from node 11. Okay, we can visit node 10 from node 11. Okay, so from 10 for node 10 the visiting time will be 11. Okay, so let me go over again. So from node 1 we are visiting node 8, 9, 11, and from 11 we are visiting node 10, and the visiting time would be 11. 10 plus 1, 11. Okay, now from 10, I mean we cannot go any further. Okay, so from 10 the child node is 8 and 11, and all of them are already visited, so we cannot go more deeper. So from 10 we are going to start our backtracking. Okay, so we'll pop the item node 10. We'll use the information of finish time. Okay, so our last finish time was 6, so for node 10 the finish time will be 6 plus 1, 7. Okay, our largest finish time was 6, so there our finish time will be 6 plus 1, 7. Okay, alright, so we'll pop the node, we'll update the information of finish time, and from 10 we'll go to 11. Okay, so from 11 also there is no other node to explore, so we'll pop the node 11. So from 11 we'll go to node 9 to backtrack, and before that we'll update the information of finish time, which will be 8. Okay, so from 11 to 9 we'll backtrack. From 9 there is also no other node to explore, so here also we'll pop the node, we'll update the finish time, which will be 9. Okay, and from 9 to we will go to node 8, so we'll pop the node 8. From node 8, because 8 doesn't have also any other node to explore, and we'll update the finish time, 9 plus 1, 10. Okay, and then we'll go to node 1 from 8, so 1 doesn't have also any other node to explore. Okay, so that means we are going to pop the node 1, and we'll update the information of finish time, which will be 11. Okay, so 10 plus 1, 11, and now stack is empty, so our loop will terminate, and that means we actually done exploring all the nodes in the graph. Okay, so you can see the tree from 1 has 2 child node, 2 and 8. 2 has 3, 3 to 4, 3 to 4 and 5, 5 to 6, 6 has 1 child node, 7. Okay, so any other edge that is not part of the tree edge, they are known as back edge. Okay, and from 1 you can see the tree edge, 1, 8, 8 to 9, 9 to 11, 11 to 10. Okay, and so for all of the node we keep track of the track of the visiting time and finish time. You can see that node 1 was the first node to start, and it was the last node to be finished. Okay, all right, so that is actually our last work example. So you can see what we did in this one. This is just a clear picture of the DFS, how the DFS algorithm will look like for the graph. Okay, so here we are using the different color to show you the internal node and the leaf node. Okay, all right, so we'll see you in the next video.